Hello everyone, welcome to the channel. In this video we will learn about the Venn diagrams. What are Venn diagrams? Actually, when we represent any of the set in the form of a picture or a diagram, that is known as Venn diagram. So we say the representation of a set in the form of a picture or diagram is known as Venn diagram, or it is Venn diagram. Why it is Venn diagram? Actually, there was a Swiss mathematician Euler who had an idea of representing the sets in the form of points on the curve. Later on, British mathematician John Venn brought it into the form of diagrams having the elements inside them, and that's why it is known as Venn diagram. What we do in this? In this, actually a universal set is represented by a rectangle and all its subsets are represented inside the rectangle with the help of a curve. Generally we represent it as a circle. Like we have first example, a universal set is 1, 2, 3, 4, 5, 6, and there is a set A which is a subset of U having the elements 1, 2, 5. U, universal set, is represented by the rectangle. We write the name U here, and the subset of it inside it with the form of a circle. The elements of this A are written inside the circle 1, 2, 5 with the help of the points, and the remaining elements of U we are writing outside A, inside U, that is 3, 4 and 6. Second example, we may have a universal set U having the elements A, B, C, D, E, F, G and H, and there are two sets P and Q. P is having the elements A, C, D, E, and Q is having the elements A, C, F, G. Here what we see? We are finding that A and C are two common elements in P and Q. And in case there are some common elements in two sets or three sets, that will be represented by the intersecting circles. So here we have P as this bicircle, Q as this bicircle, and the common elements will be written in the intersecting part, that is the common area or common region of the circles. So we have written A and C, the elements here. The remaining elements of P will be written here as D and E, and the remaining elements of Q are written here, F and G, and the elements which are left in U now, they are B and H written here. Suppose two sets are not having any common elements, like we have this example. In this, U is same A to H, and then X is having the elements A, B, D. Y has the elements C and F. There is no common element between them, and then we will be writing the sets in the form of this. The Venn diagram will be representing two sets which are away from each other, not intersecting each other, and the elements of them will be written inside them, and the remaining elements of U will be written outside these two circles. The next example we have with three sets and the universal set. The universal set having the elements 1, 2, 3 up to 10. X has the elements 1, 2, 4, 6, Y has 1, 5, 6, 7, and Z has 1, 2, 5, 8. All the sets are having some common element. It means all the three sets will be intersecting each other. The element common to all the three X, Y, Z we are finding is 1. So 1 will come in the commonmost area which is common to all the three. Then we write the element which is common to X and Y. In X and Y we find 1 and 6 are common. 1 we have already taken, so 6 will be coming in this common area. 2 is common with Z So 2 is coming in the common area here. And then the remaining element 4 is coming here in the area. Likewise, here we find in Y the elements are 1, 5, 6, 7. 1 has come here, 6 has come here, 5 is common with Y and Z. So 5 comes in the common area. And the remaining element 7 is here. Same way when we go to set Z, having elements 1, 2, 5, 8. 1, 2 and 5 already come here. So 8 is the element coming here. Likewise, we can represent all the elements of X, Y and Z in this. The remaining elements of the universal set, like here 1, 2, 3 has not come. 4, 5, 6, 7, 8, 9 and 10. So these are the elements coming to the area of the universal other than X, Y, Z. Representing subset of a set. Suppose A is a set having elements 1, 2, 4. B is another set having the elements 1, 2, 3, 4, 5. We find that A is a subset of B. That is proper subset. It means set A will be completely lying inside B. So we draw a circle to show or to represent B. And inside it we represent this as set A in the form of a circle. The elements of A 1, 2, 4 inside this, and the remaining elements of B are coming outside it. Now suppose we want to find some operation and represent it in the form of Venn diagram. I'll take one example here. Of course, in the next video we will be learning about the operations on sets, and then along with the operations we will be going with their Venn diagrams also. In this I am taking only one example, that is, suppose we have a universal set U having the elements A, B, C, D, E, F, G. A is a set having the elements A, B, D, E, and B is the set having the elements A, D and F. A and D are common elements, so they will be intersecting sets. AD is the common part, so common region will be representing these two elements A and D. Remaining elements of A, B and E are here, and the remaining elements of B, that is F, is here, and the remaining elements of U are C and G outside A and B. Now suppose we want to show only the common part of A and B, that is known as intersection of sets. Intersection of A and B, and that is represented by A intersection B. This is the common area, common region will be representing A intersection B here. So to represent the answer, to represent the part which is representing A intersection B, we will shade this part like this. So this is the portion which is representing A intersection B. In the next video we will be learning about the operations on sets, and along with that we will be going with the Venn diagrams of that particular operations also. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.